Hi crew, we're going to practice multiplying decimals today. Need a good review about this. First thing we need to do is when we're looking at decimals like 3.5 times 0.4, you have to know how to set the problem up correctly. So when you rewrite this problem, it doesn't matter which one goes on the top or which one goes on the bottom. You know that property, your commutative property of multiplication. It also does not matter if you line the decimals up. Now, since these decimals only go to the tenths place, naturally the decimal is going to line up. And I know you recognize that from adding and subtracting, but when you multiply, this does not matter. Lining those up doesn't matter. You'll see that in the next problem. Let's go ahead and multiply. We're going to pretend like the decimals aren't there. We'll deal with them at the end of the problem. So our first step, 4 times 5 is 20. We'll put down the 0, carry the 2. 4 times 3 is 12, plus 2 is 14. I'm going to put down the 14. Now our other digit is a 0. I don't need to go through and multiply all of those. I'm ready to place the decimal. Now here's the trick. You have to count how many digits are to the right of the decimal in the problem. Well, there's 1 to the right of the decimal in that number, and there's a second one, 2, because there's 1 to the right of the decimal in this number. Well, down in the problem, we need to make the same number of digits to the right of the decimal as in the problem. So there's 2 in the problem, so down below we have to make sure there are 2. That means the decimal would go right here between the 1 and the 4. So that means our answer is 1.4. Now, can I add that 0 on the end here of this? Certainly. But does it change the value? Absolutely not. You can leave it or you can put it on if you want. All right, so let's do the next problem. The next problem is might help you see a little bit more of setting it up, how you doesn't matter how you line up the decimal. So if I have 3.42 times 4.7, notice the decimals are not lined up. Now if you keep doing that, then I know you learned a lot from adding and subtracting decimals, but it does not have to happen in multiplying. So you're going to go ahead and multiply as usual. 2 times 7 is 14, carry the 1. 7 times 4 is 28, 29, carry the 2. That would be 21, 22, 23. Now there is another digit. I have to add a 0 for the placeholder and go ahead and multiply now. I'm ignoring the decimal till the end of the problem. 4 times 2 is 8. 4 times 4 is 16. I carry the 1. Cross that off. 4 times 3 is 12. Plus 1 is 13. I have got myself squished here. And I'm erasing. I'm going to write my answer up here. So that would be 4 plus 0 is 4. 9 plus 8 is 17. Carry the 1. Okay, this was a 6. That would be, this was a 6. 9 plus 1 is 10. I'm going to carry the 1. That would be 5. Plus 1 is 6. And just 1. Now I need to place the decimal in this. How many numbers were to the right of the decimal in the problem? Well, I go through and I underline them and count. 1, 2, 3. Now in my problem, my answer, I have to have the same number of digits to the right of the decimal. 1, 2, 3. So my decimal would go right there. And there you have the problem. Now let's do one more that has to do with lots of zeros in it. This is actually one of the easiest kinds of problems. You always want to put the number that has the least amount of whole digits on the bottom because that's a shortcut. You want to do the least amount of multiplying as possible. I think that's always a good idea, don't you? So we're going to rewrite the problem 6.01 times 0.002. Now I'm going to just multiply using just the 2 digit. 2 times 1 is 2. 2 times 0 is 0. 2 times 6 is 12. I don't have to multiply any more with these zeros, but watch what I do have to do. How many numbers are to the right of the decimal in the problem? There's 1, 2, 3, 4, 5. But in the answer, look how many digits there are. 1, 2, 3, 4. Well, you have 5 in the problem, and remember I said you have to have the same amount of digits to the right of the decimal in the answer. So it's very simple. Remember, we didn't multiply all these zeros. If we would have had a lot of extra zeros. I'm simply going to add a 0 to the front of this number, and now I have 1, 2, 3, 4, 5 digits to the right of the decimal, just like in the problem. Also remember to add a 0 to the front of this. We want to protect that decimal. We don't want to leave it open like this. So this would be your answer. You just have to fill in with another 0 there. That 0 completely changes the value. If you're not comfortable with that trick, go ahead and multiply out all those zeros. I think it's a lot of extra steps. If you just learn to count 1, 2, 3, 4, 5, make sure it matches the number of decimals, the digits to the right of the decimal in the problem, you are all set. Hope that review helped.